Welcome, student. In this session, we would be discussing about cryptanalysis. So, we can perform two types of attacks on a crypto system. One is cryptanalysis, another one is brute force attack. Whereas cryptanalysis relies on the observing or looking for vulnerabilities in the design of the algorithm or the nature of the algorithm, plus some knowledge about plain tests and cipher tests. Whereas brute force attack relies on trying all the possible combinations of keys until you get a plain text message. On average, one would perform or try half of the keys to achieve success. So we have various types of cryptanalytic attacks. In ciphertext only attack, the attacker has knowledge about only in the encryption algorithm and ciphertext. With this knowledge, he has to recover the key. In known plain text attack, the attacker has knowledge about encryption algorithm, ciphertext, plus one or more plain text ciphertext pairs. In chosen plain text attack, the attacker has knowledge about encryption algorithm, ciphertext, and the attacker introduce a plain text message into the system somehow, and also able to get the corresponding ciphertext for that plain text message. In chosen ciphertext attack, the attacker has knowledge about encryption algorithm, ciphertext, and he introduces some ciphertext message into the system somehow and able to get the decrypted plaintext message for that ciphertext. In chosen test attack, the attacker has knowledge about encryption algorithm, ciphertext, and then he introduced some plaintext message into the system somehow and able to get corresponding ciphertext. Similarly, he also introduces some ciphertext message into the system somehow and able to get decrypted plaintext message for that ciphertext. Among all these attack, uh, performing ciphertext only attack and recovering keys highly impossible because the attacker has only limited knowledge. So ciphertext only attack is ruled out for modern ciphers. Whereas known plain text attack and chosen plain text are the popular attacks, are mostly used attacks. And then some people also use chosen ciphertext attack, but where more knowledge of informations is required. Chosen test attack is also highly impossible because the attacker needs to have a large volume of information. Now we'll be discussing about side channel attacks. Whereas classical cryptanalysis focused on exploiting the vulnerabilities of the algorithm or design of the algorithm, whereas side channel attack focuses on the exploiting vulnerabilities in the implementation of the algorithm. So examples of side channel attacks includes timing attacks, power analysis attacks, and electromagnetic attacks, and some other attacks also. In timing attacks, say different plain tests and different cipher tests have different encryption and different decryption times. So observing those differences is timing attacks. Similarly, for power analysis attack also, different plain tests and cipher tests have or consume different amount of power for encryption and decryption. Similarly, electromagnetic attack, here too, different plain tests and cipher tests produces different electromagnetic leakages for encryption and decryption. Based upon those differences, these side channel attacks are mounted. Differential cryptanalysis. Here, the attacker will choose plain text blocks with particular exclusive or difference, and then they will observe the differences in the resulting cipher text pairs. Based upon these observations, okay, they will try to recover the key. Here you have two variants. If you use known plain text attack, the number of operations required is 2 power 55.1 for desk cipher, and it is drastically reduced to 2 power 47 for chosen plain text attack. Now let us discuss about linear cryptanalysis. Linear cryptanalysis makes observation about the statistical linear relationship between plain text, ciphertext, and key bits. So, based upon those linear relation, uh, the attacker is able to predict the values of the bits of the keys. When number of plain tests and the corresponding ciphertext are increased, then making this attack becomes more easier. Here, the known plain text attack variant requires 2 power 47 operation to perform linear cryptanalysis. So both differential cryptanalysis and linear cryptanalysis, theoretically it is possible. Practically, it is not that possible because the attacker needs to have that much amount of information. So now let us discuss about brute force attack. The total key space is 2 power key size. For example, in this we use 56-bit key. Therefore, the key space is 2 power 56. Similarly, for AES, if you use 128-bit key, then key space is 2 power 128. So the number of operations to break in average cases half of the key space, that is 2 power key size minus 1. For example, in this, it required 2 power 55 operation. For AES with 128-bit key, it will be 2 power 127 operations. So this table represents the brute force attack for different ciphers. The actual time taken by using high-end computers. So with modern computing power, we can crack a desk cipher in 1 hour. Whereas for AES, for different key size, it will take trillions of years to break AES with current computing technology. So with this, I conclude this session. Thank you.